In this video, we are going to look at what's called product to sum identities or summed product identities. So first you have to know the identities. So you can see I've got these two tables here. This first table is going to be product to sum. So what you notice is that on this left-hand side, I have the product between my sine and cosine terms, and then on this right-hand side, it gets expanded into a sum or difference. Now, on this other table, we have sum to product. So what this means is that on the left-hand side, we're starting with a sum or a difference, and we are going to end up with a product. Now, if you look very carefully, starting with my product gives me a very different look to a sum versus my summed product. So please don't get these confused. These tables do not interchange with each other. They are completely separate, and thus you want to view them as. Now you will use these identities to be able to find the identity of the given problem. So what's going to happen is you're either going to be given a product or you're going to be given a sum or difference. And what you're going to be asked essentially to do is to expand that out into its counterpart. Okay? So I've got a couple examples here that we're going to look at so you can kind of see how these identities work. So this first one is the sine of 7x minus the sine of 4x. So the first thing you have to identify is you have to identify what this operation is. So here we have a difference, which means we are going to be using the sum to product side. Now if we look, I have sine minus sine. So if I look here in my table, I've got sine plus sine, sine minus sine, cosine plus cosine, cosine plus cosine. And pay very close attention to the fact that your x and y values may change places. Okay, and so here I'm going to use sine minus sine. So I've got the sine of x minus the sine of y. So the identity I'm using is sine of x minus the sine of y is equal to 2 cosine of x plus y over 2 sine of x minus y over 2. So this is the identity that we are going to focus on. If you look, that means we need to identify the x and the y. So here I have sine of 7x. So this means my x term is equal to 7x. And it means my y term is equal to a 4x. So once you know which is going to be x and y, you simply have to plug them in. So I've got the sine of 7x minus the sine of 4x is going to equal 2 cosine of x plus y, so 7x plus 4x divided by 2, sine of x minus y, 7x minus 4x divided by 2. So you simply have to reduce. So this is going to give you 2 cosine of 11x divided by 2 sine of 3x divided by 2. And this is all you have to do. There's nothing more complicated than that. This is what we were looking for. Alright, let's take a look at one more. So here I have 7 cosine of 5 theta times cosine of 7 theta. So this is a multiplication. So here we're looking at the product to sum identities. And we have cosine and cosine. So here we've got sine of x, sine of y, cosine of x, cosine of y, sine of x, cosine of y, cosine of x, sine of y. So we have to match the identity to what we've been given. Well, we've been given a cosine-cosine pair, so we're going to use the cosine-cosine identity. So that identity, again, is going to be that we are using the cosine of x times the cosine of y is going to be 1/2 times the cosine of x minus y plus the cosine of x plus y. Okay, this is the identity that we are working with. So just like before, we have to identify what my x and y is. So in this case, my x term is going to be 5 theta, and my y term is going to be 7 theta. So here, I also have to keep in mind that I have this 7 out in front. So I have 7 cosine of 5 theta, cosine of 7 theta, and that is going to equal 7 times my 1/2 cosine of x minus y, so 5 theta minus 7 theta, plus the cosine of x plus y, 5 theta plus 7 theta. So let's simplify. 7 times 1/2 is going to give me 7/2. And then I'm going to have the cosine, and I have 5 minus 7 is going to give me a negative 2 theta. And I have plus the cosine, 5 plus 7 gives you 12 theta. Well, we have to recall a little rule. So here we need to recall that the cosine of a negative value is the same as the cosine of the value. Okay? So in this case, we can simplify this further to say that we have 7/2 times the cosine of 2 theta plus the cosine of 12 theta. And once again, that is going to be your exact value. And the reason for that is because we don't know what that theta angle is. And so here, that is all we were asked to do, was simply apply the appropriate identity to our problem. So if you have any questions about your product to sum or sum to product identities, please let me know. Otherwise, I hope you have as much fun as I did. Remember to be creative, and I will see you next time.